Formal intro time. Hi, good afternoon, and welcome to everybody who is in the room. My name is Robin Huggins. I work for a business called MBN Solutions. It is my absolute pleasure to occasionally be the host of the Scotland Data Science and Technology Meetup, which is a kind of joint thing between MBN Solutions and the Data Lab. Welcome to all of you. Thanks for taking some time out your day today to come and hear the man, Dr. Andrew McMahon, published author, Dr. Andrew McMahon, who is a ML engineering lead at NatWest Group, and a right good mate. Andy, welcome. Thank you so much, fella.
No, thanks for having me, Robin. Delighted to be here as always. Hi, everybody in the room and all the people streaming in. So I'll just kind of kick off then. So as Robin says, I'm ML engineering lead at NatWest Group. I'm speaking today more in a personal capacity than representing NatWest. The reason for that is really I'm going to occasionally plug the book that Robin mentioned shamelessly, because some of the stuff that I've written in there are just my thoughts from my kind of career, thinking about how do we take the concepts, the ideas behind these subjects, ML engineering and MLOps, and as part of this call, we'll kind of explore what I mean by that and how I think about it. How do we take these concepts and actually make them real, which is probably something that interests a lot of you, interests your organizations you work for, or kind of the wider community, I think. There's a lot of really good talk about the theory behind this, the tooling, the platforms, the architecture even, but at the end of the day, we need to get down and code stuff and actually build stuff that works. And I'm kind of going to just put together a bag, if you like, of kind of some of my thoughts on that. So let's kick off. So first thing to talk about is some preamble. So the title of my talk, Just Build It, is obviously slightly tongue-in-cheek. I don't really think that you can just kind of walk into a room or walk into an organization and just start building. You have to do all the usual very important things. You have to get stakeholder engagement, you have to get funding, you have to build a team. And I've got some kind of appendix slides about some of those things. But the talk today is more focused about, imagine you've got some of that in place, you've got the environment set up, people are keen, they're hungry, they want MLOps and ML engineering in the business. What are you then going to do? And the objective here is to really help you and the others you work with and maybe your teams let go of the fear of getting started, because I think this is a very complex topic, or it can be complex, but there are ways to simplify it. And I think that we're very much in this space, this MLOps space, where we were with data science a few years ago, where we can do certain things well, but we're kind of not seeing the full picture yet. And that might lead to a bit of analysis paralysis, which I'll come on to later. And then kind of, I think, just thinking about some phrases that capture my sentiment on this and how I generally lead teams in this space and think about these projects is it's really good to have a bias for action. So try and think that execution is key. You can plan too much. I've got George Patton up here, the general from World War II, whose quote I kind of like: "A good plan today is better than a perfect plan tomorrow." He actually said something like, "A plan violently executed today is better than a perfect plan executed next week." But I think this one's better. It's a bit more sanitized. So basically, moving forward sometimes is good, and that is very good in this world, that especially in technology now, where we always talk about doing agile and working agile and lean and these sort of methodologies and ways of working, that there is a bias for action inherent in those ways of working, and we should do well to remember that. Also think as well about bootstrapping your capability. That's a really big thing for me. Don't think you have to like become the target straight away. You don't have to become this perfect MLOps team right away. It's just not feasible that way. What you have to do is slowly, incrementally build your capability, build your confidence, your understanding, your knowledge, your skills. And I'll really talk about that through it. So that's kind of like Yoda sort of saying, do or do not, there is no try. I think just get stuck in, start those little things, build it up. Don't kind of think, oh, there's this huge thing and I'm going to try it and probably not get there. It's good to be ambitious, obviously, but understand there's a road you need to walk. You can't just jump to the end. And then finally, kind of, I think, attempt what you're not ready to do, and you'll learn faster. In a nutshell, is what I'm kind of saying here. So although you work incrementally, it is good to stretch yourself for each of those incremental steps. So they're achievable, but they are stretch goals. And you don't feel at the beginning you're exactly ready to do it. That means you're learning. And then the kind of final quote I've got up here in my little hall of fame of quotes I sometimes think about is by this guy, James Clear, who wrote the book Atomic Habits. And I absolutely love this. He's paraphrasing an ancient Greek philosopher. I can't remember Hephaestus or something, I can't remember. But he basically said, you do not rise to the level of your goals, you fall to the level of your systems. And I think that's absolutely right. So on the one hand, you're going to have this upward pressure where you're chasing these next things you want to bootstrap and build confidence on. But at the same time, what you have to do is pull the systems you're building with you. And what this whole bootstrapping capability idea I've got is really about making sure that the systems are coming with you up and up every time, so that you look back at yourself and your team a year from now and you almost can't recognize where you've gotten to. So, but you've done that through a bias for action, loads of small steps. So that's the preamble. That's kind of the goal. That's what we're after. That's what making it real sort of means to me. But what are we trying to make real is the next question that comes to mind, right? So I've said these two words, these two practices, ML engineering and MLOps, and they're sometimes brought together, they're sometimes separated out. We've all got different views on them. I don't think there's a settled view what either are. There's no settled dictionary definition yet, or at least there's not one I'm aware of. So in my head, here's what I think about these disciplines as, or these things as. ML engineering is really the practice, the capability of getting your data science models into production. And we'll talk more about that later, what that means. But getting your models into production by applying enough software engineering. So what you're doing is bringing the world of software engineering and machine learning together. We'll talk about that a bit more in the next slide. And then MLOps is really about the end-to-end life cycle management of those models and the solutions you're building through ML engineering. So you could say ML engineering is contained within MLOps. You could say, I kind of view it this way, ML engineering is a precursor to MLOps, something you learn on the way there. But they are related, but slightly different. So MLOps is a bit more wider encompassing. It's a bit more of a culture thing. ML engineering is a bit more about concrete practices and how you actually build things. And then kind of another angle on that I think is important to bear in mind as well. And this really helps if you're having conversations in your business with stakeholders and you're sort of throwing these terms about, because it's how you rationalize and think about these things. But people have a hard time maybe mapping it to the worlds they're comfortable with and know. So I speak a lot with people who have been, say, project managers, scrum masters, tech leads, etc., but years ago on more traditional software engineering projects, and they just kind of, they don't really map directly what we're talking about when we say these new terms, or these terms more specifically focused to data science, I would say. So for me, software engineering maps quite nicely to ML engineering. It's a set of disciplines with tools, tech, processes, best practice. We'll discuss some of those best practices, in my view, that I kind of think are important and really helpful for building your capability. And then there's DevOps mapping to MLOps. So DevOps, if you read about it and you look into it, the literature, it's not really a specific set of things you do. Some of it is, right? So like what will come to our mind if you know about DevOps, maybe CI/CD, continuous integration, continuous deployment. That's certainly a piece of DevOps, but it's not DevOps in its entirety. DevOps is about having a culture of blended responsibilities between your development and your operations, as the name suggests, right? All you're doing here is mapping it into the world of machine learning. So what you're saying is, I want a blended world between my machine learning team, my data science team, and my operations team. So you're taking that world of the idea and the world of production and joining them together. And again, that'll be a bit of a running theme through the slides. Okay, so I think that's some initial preamble. Let's start making it a bit more concrete, a bit more real. And then what we'll do is we'll just keep kind of gradually going in a lower and lower level. So I sometimes think about MLOps as an inductive process, if you like, from mathematics. So apologies to MD who's got a math background or knows about this, but in mathematics, a proof by induction is when you want to prove a case for all the natural numbers, so n equals 0 and up, all the positive whole numbers. So what you do is you prove the first case, so n equals 0 or n equals 1, whatever your definition wants to be. You prove that case is true. And then what you do is you prove that in general, if one case is true, the next case is true. And then what happens is the whole thing falls as a set of dominoes and you can go up to infinity. So for me, that relates to what we're talking about here, because n equals 0, the first step, the first sort of proof in this maths version of reality is getting your first model into production. And to me, that's an inherently different exercise from getting the next models into production, because it's the first time you're possibly thinking, We'll cover some of this. How do you wrap this in a pipeline? How should I write the right code? What's the right process and practice I should build in there? Again, mentioned before, technology sometimes over-egged as a topic, but it is important. What technology do I use? What platforms? How am I hooking things together? All of these are kind of questions you confront the first time when you get that first model into production. So that for me is your first case. That's when you start building that foundation to then be able to do this infinitely many times if you have that much budget. So that's how you learn ML engineering, getting that first model into production. Then the N+1, so the first, the second, the third, etc. model into production, given that you've got the first model into production, to me, is MLOps, right? Because you're now managing an end-to-end life cycle where you've already got a working model in production doing its job, and you're coming up with a new thing that you want to either swap out or at least challenge against it, or you want to do some kind of A/B test, however you want to do it. You have to manage the transition seamlessly because you're in production, you're providing a service now. What you have to do is manage that transition seamlessly, make sure you're in control of that end-to-end process. And that to me is MLOps, right? So it's maybe a tenuous link between a maths thing I heard about 100 years ago in uni, but I do kind of like thinking about it this way now. So first model into production is ML engineering, the N+1 after that is MLOps, right? Or at least that's how you get your first exposure to these. So in my book, which mentioned earlier, that I will shamelessly plug, so it's on the top right here. So whenever you see that little icon appearing, that's saying that this concept's referred to in my book that's just appeared. So in the book, I talk about how I think any machine learning project can be decomposed into 4 steps. Could be more in your terminology used, could be 5, could be 3, doesn't really matter. But I think there is definitely 4 steps you have to go through. And that to me is you first do discovery. So you understand the business problem, the requirements. You try and just understand the landscape you're operating in, what problem are you trying to solve. You then play. So what I mean by that is you build the first prototypes, you get the Jupyter notebooks fired up, you get some sample data, you start understanding how you could solve this problem in practice. And then you settle on an approach that you want to take through to the next stage, which is develop. So that's when you develop in a more professional way and you start doing that ML engineering piece and really thinking, how do I bring all this together and actually develop a solution? And then there's deploy. So you have to deploy the solution. So whatever solution you build, you put into production. Then just tying this back to what I've just been saying, the first time you go through that, that's your ML engineering, because you come across a lot of new stuff. How do I build properly? How do I get into production? And then the next one is when you start thinking, right, I have to, no matter what I do next, I have to consider this as a whole. Everything that's gone before, I can't just forget. So it's not a one-shot process. So that is, to me, a good labored set of explanations of ML engineering and MLOps. But I think they are important because they're good ways to get in your head and then to the people you communicate with what you mean when you're doing these things. And it also helps you understand what challenges you'll face that are slightly different, which I'll come on to in the next section. So one of the challenges that I want to get us over, so now we've got that kind of understanding, we've agreed on terminology. Where are some of the challenges we need to face? So for me, there's one big one that I want to just kind of get us to brush aside, which is analysis paralysis. So this fear of getting started. And I think a thing that's really driven this recently is the proliferation of tools for a lot of components of what you want to do in ML engineering and MLOps. So here I've just got a brief selection of some things you'd maybe want to use for, say, model management. You've got your ML flows, your comets, right? If you want to do sort of bias detection and drift detection, etc., you've got Arthur, the True Error, the Fiddler. You've got things that are a bit more wider platforms, the data IQs, etc. So there's pipelining, Kubeflow, Kedro. There's just so many tools, right? And it's so easy to look at all that and go, I really don't know where to start. So I'm going to take a long time. I'm going to try them all. And I'm going to do a big sort of matrix of pros and cons of each of them. And at the end, I'll make a decision and I'll ask for budget. What kind of would ask you please to bear in mind is what I said earlier. Have a bias for execution. Just pick the easiest one that you think you can get started with off the shelf and start playing with it, using it, going through this cycle. Because if you can do it with one of these, I argue that you could swap out for a lot of them easily later. The key thing is getting the best practices in the process and the understanding there. It's not really about choosing the silver bullet tool because one doesn't exist, right? you will be able to swap them out depending on, you know, market conditions, the budget you've got, your appetite for certain types of license, whatever the criteria, you will be able to sort of swap these out, I think, later on. So analysis paralysis is a big challenge I want us to confront and kind of hit on the head, basically. So that's the challenge, or one of the challenges. What are we gonna do? So I think the first thing we need to do is identify where the challenge really manifests itself. And I think for ML engineering, MLOps, the problem lies in this place and that sort of step, those 4 steps. I said it's really in the middle, and I call it the chasm, if you like, sometimes when I want to be a bit dramatic. So on the left-hand side, we've got the idea you initially have, that thing that's crystallized from discovery, your understanding of the business and the data. And on the right-hand side is this kind of not very often visited land called production that we know we want to go to and we've heard great things about, right? So the problem is, how are we getting there? There's this chasm in the middle that not many people, I would say, have personally walked on. Not many organizations kind of walk very often. So what often happens is your idea starts really good and then you just lose your way, and you lose your direction a bit and you fall into this, what I call model limbo. So I think there's so many models, amazing pieces of analysis and understanding and data science out there that I think are in this limbo state where they're there. We know they'd be really beneficial. They can be beneficial if we sort of run them once a month manually and put the results in a PowerPoint slide and someone takes decisions on them. Nothing wrong with that, but there's a desire there, I think, to take a lot of these models and actually get them through production so that they're feeding APIs, so that they're feeding backend solutions, so that they're helping drive decisions at kind of a more automated level. So how do you avoid your model falling into this limbo state? So one thing you have to do, building on what I said before, is take it step by step, right? So you want to build a kind of road between the two, a path that you can walk back and forward quite comfortably, and you do that incrementally. So little bits of that bridge were appearing step by step. That's important, I think. You don't want to take kind of the big leap, because you might not make it, or you might make it the first time, but then the next time you do it, you've kind of spent your resource, or it was such a stressful exercise, everybody left your team, right? What you want to do is incrementally get there with a plan, with a roadmap, stretching yourself each time, but at the same time, just building up your capability. So that to me is kind of the key thing we're after. And now we'll start talking about how we actually do that. So this is the making it real part. So in detail, the way I think you do this, and the way I've tried to do this in my teams and sort of my projects, is you get the project roadmap you've got, or the pipeline of work you're going to have to do. It could be for the year, could be the next few months, whatever your time scales. Just know that you're going to be doing project after project after project after project. If you're successful and lucky, which you should kind of be confident you are, right? Think of Yoda, do or do not, there is no try. So what you do is you think, right, I'm going to have these projects coming along the line. What I'm going to do is I'm going to start picking off some of the simpler things that I can do that help make my solutions more robust and I can build on. So number one could be, right, I'm going to get my data scientists using the concept of version control. So we're going to look into Git flow workflow. We're going to understand the concept of pull requests and code reviews. We're going to start understanding how that all works and really have a good branching strategy in our code. Good. We're also going to get people clued up in the team on packaging. How do we build good Python packages? How do we control the environments they're in? How are we going to basically take things, rather than having really long notebooks or really long scripts, how are we going to package it up nicely so it's reusable across different projects? So you maybe start there. And then your next project, you think, right, I'm going to build on that. I'm going to introduce the idea of unit testing. So what I'm going to do is get a bit more software knowledge into the data science team. So they're already doing version control and packaging. We'll now write our unit tests. So we start with something like PyTest, or it could be a Cucumber or anything. It could be basically whatever framework you choose. But you start saying, right, I'm going to write these tests, and then what I'm going to do is see my unit test coverage, and I'm going to build more confidence in the solutions I build. So when I go through production, I'm more confident that they won't break. I'll then go a bit more ambitious, and I'll start bringing some of those DevOps concepts into the fray. So I start moving towards MLOps. So I'll explore continuous integration, continuous deployment. I'll maybe look at GitHub Actions or Jenkins or TeamCity, whatever solution I want to use. Again, doesn't matter. You can swap them in and out. I'll start understanding what CI/CD means and how I can do it. And again, just building on that, we could go into configuration or infrastructure as code. We could look at experiment tracking. So how do we start tracking the experiments of our ML models? How do we start monitoring their performance once they're in production? Understanding when they're going out of tolerance, when the performance is drifting, I'm getting feature or concept drift, etc. And you just keep going. And then, as I said before you know it, you're a year down the line, you've done a few of these projects and you say, right, we're actually building quite slick professional code that's well tested and I can get through deployment in an automated way. Amazing. Or even better, I've kind of went all the way to 0.789 here and I'm starting to do MLOps in a way that gives me real control over models I get into production. And that's pretty powerful to me. So just words kind of to think about when you're going through this. And I would recommend trying to think about your plan for this, what bits you would want to tick off as you go through. Start small and ratchet up. I didn't start straight at performance monitoring or start straight at infrastructure as code. I've not made any assumptions here, and you might have a team that's actually, oh, we already do 1, 2, 3, 4, Andy. So start thinking about the later ones, or you're actually like, we're already doing a bit of 6 and 7, but we've not really nailed down 3 and 4. This is not prescriptive, right? But what we'd say is for your team, start small where the gaps are and ratchet up, bootstrap that capability, get bigger and bigger, more confident and bold. Remember as well that working's better than perfect. So one thing I kind of can't abide by in my projects is that looking for perfection. What you want to do is just be really clear what your goal is. You should do this in any project, right? But do it as well with your capabilities. So what is good enough for each of these? So everybody following Git flow all the time, very rigorously, etc., is a great goal. But if it's not quite happening, but you're 90% of the way there, that's probably good enough to just move on and keep building it, and then you'll pick up that last 10% as things progress. Because people should hopefully see the benefits and all this in itself. And then just remember, you'll never be done. There'll always be more things you can improve. You can come back. Your kind of the capability you're increasing by might get smaller and smaller as you become more capable, but there'll still be things to do. You might want to go back through the loop again and pick up things you've already covered. But that in a nutshell is the concept, right? And that's how you do it in real life. So do some concrete examples of that, and then I'll kind of finish up, because I think it's good to, again, just give an idea how you'd actually take that idea and make it a bit more real. So apologies, I've got cleaners in if you can hear the Hoover. So getting that first model into production, what should we be thinking about? So first thing for me is get a pen and paper, write down what production means to you. So for me, it's an isolated environment with strict controls. It's got defined risk profile. It's got service level agreements. It's a place where you're doing real business with your data. In a sense, you have to trust that it's going to work. You can't just put in something you kind of did on an afternoon that wasn't too hard and you didn't test too much. That's not what this is. It's the real deal. It's the place where your real inference happens in a productionized ML solution. So whether it's a recommendation engine, forecaster, clustering, doesn't matter. It's where the real prediction or inference happens that is going to be used downstream by something else or someone else. And then it's where your request response traffic goes. So just thinking about that, that's going to be where things are, the requests and responses are exchanged. So there's going to be mechanisms in there for that. And you have to think about contracts between inputs and outputs and things like that. How are you going to get there? Sometimes it's good to sketch that out at the first stage as well. So I would say forget about notebooks. I can definitely have that argument with people. There are good examples and talks I've seen online where with certain tools you can take notebooks all the way through to production. There are tools for that, ways of doing it. It's just not my cup of tea. Maybe you can make it work, but I kind of feel like you should be writing it as if you're building software in a more traditional sense. So building your packages, your modules, your containers, etc., rather than thinking in a notebook world. I think notebooks are absolutely brilliant for the early stages of a data science project, absolutely, and good for exploration and explaining of certain things. But I think for kind of building the end product, I like going that traditional software route. Think about, again, map out some of the stuff you want to pick off in the later stages. So you might want to learn about packaging, linting, testing, building, version controlling, all the stuff I mentioned before. And then for production to be production, it's important you follow a clear route to live with appropriate promotion mechanisms. So what I mean by that is, does your organization have the concept of a dev, pre-live and prod environment, or dev, pre-live, live, etc., or dev test live, whatever you're calling it? do you have the concept of lower environments for sort of anything goes and we can build whatever and there's no repercussions really, and then gradually you're tightening the grip and the envelope of safety until you get through to production so that you're confident what you're putting into production is safe? Do you have that, or how can you work out how to build that? Some of the second things I like to think about, so ML Engineering 102 if you like, is start thinking about the code. So a little icon from the book again. Here's examples from the book. So on the left hand side I've got some notebook code that I wrote to do this kind of exploration of building a forecaster with profit. So you can see I'm using pandas data frames, I'm doing some time series splits. I've got a data frame called temp. I've got some matplotlib code to do plotting, right? All this is good stuff for exploration, but I can't take that into production. That's not good, and it's not kind of built in a really software engineering way. So what I have to think about is how I map that to what I want. So on the right hand side, you can see what I've done is, once I understand how I want to train this model and how I want to interact with the services I'm using, I've decided to build classes. So I went object-oriented programming. I've built methods in there to like get the prediction metadata, get the latest predictor, train a new predictor, create a new forecast. What I've done is standardize things, and I've implemented some software engineering tools, tips and tricks like separation of concerns. So the trainer is one job or one set of jobs related to training, and then the methods that's in the class trainer all do one thing. So create latest forecast creates the latest forecast, and that's it. And what that does is helps things be a bit safer, more resilient. So if create latest forecast fails, that's all that happens. The latest forecast doesn't run. Whereas if I had everything in one giant script and the first bit failed, the whole thing wouldn't run. I've got simplicity there, so keep it simple, stupid, something I like. That eventually came into software engineering. I think it was originally, again, a US Army quote. If someone knows, please put in the chat. But by keeping each method simple, what I do is, again, I make them easier to debug, easier to maintain, easier to further develop. And I actually make them, the final point, unit test friendly. So I can start writing clear tests for each of these that it's very clear what the failure and pass criteria is going to be. So start thinking about the code. How far away are you from where you are in the code you want? And again, the wee book icon, I cover a lot of that in a bit of depth in the book. Then the last point on MLEng, I think, I made the second last point, is about starting to think about deployment. So don't be scared of CI/CD. I think a lot of people in the data world maybe who haven't been exposed to this traditionally and not learned about this when they were doing their initial courses, degrees, or transitioning into the area. It's not as difficult as you think. So CI/CD is definitely your friend. Think about looking at GitHub Actions, Jenkins, Code Pipeline, Code Build, and AWS. It's going to help you automate stuff, which is just brilliant, makes your life so much easier. And then you can start introducing things like checks and balances, like minimum test coverage or data quality checks before you go through that promotion mechanism I mentioned earlier. So here just to show you how simple it can be, right? On the right-hand side, I've got a YAML file that is for my GitHub Actions steps that I used, again, in the book to show how to deploy. I think, yeah, it was a DAG for a certain machine learning process on Apache Airflow on AWS, right? Lots of great words in there. Sounds complicated. It's not. It's 34 lines. Some of that's comments and spaces, right? So it's really about 20 lines, 25 lines or something of actual code there. And what that does is it says, upon a pull request into the main branch, I will then upload this latest piece of the code. So I'm already starting to do continuous integration and continuous deployment, but it was only 34-line YAML file and hooking into an existing tool. I think start thinking about that early is good as well. And then final point in MLEng, this is the final one. Think about how to make your configuration of your solutions simpler. So YAMLs, I've already mentioned, is great for this, and there's really a lot of great tools out there to help you build YAML-based pipelines. So in the YAML, you define a lot of the standard parameters and configuration you want for your tool that you're building, and then you can change them. And what it means is you're starting to separate out what's instance specific. So I want to run on a daily frequency versus a weekly frequency, for example. That's a sort of instance specific thing. I could feasibly do that with the same model on similar data coming in, which is just a change I want to make depending on the instance I want to run, versus what's generic application logic code. So the thing that runs this model is pretty much the same, whether I run it daily or weekly or whatever the parameters. So YAML and thinking about separating out configuration is good to do that and help reduce complexity. So Hydra is a framework that I really like that is good for managing that sort of set of YAMLs, and it's a good one to Google. It was open source by Facebook a couple of years ago. So really recommend looking into Hydra. Good. Not long to go, and then we'll stop for questions. So that's MLEng, and now we're talking about the MLOps piece, right? So you've maybe built quite a good process to get yourself into production the first time. What do you need to think about when you're doing it again and again? So another big thing I cover in the book is model management. So here I've got some of the stages of that process I mentioned earlier, the play, develop, deploy stages. So I've left out discovery for now. And here what I've mentioned is where certain elements of common model management tools can support these stages and what you're doing. So this is couched in the language of MLflow, one of the tools you can use, but any tool pretty much in this space has these capabilities. So tracking is really about experiment tracking. So you run 100 different models or 10 models with 100 different hyperparameters, and you want to understand the performance of each one and track that. The tracking capabilities in these solutions help you do that. Model registry, the next stage, is a bit more sophisticated. So that's about taking the models you've got and tagging them as production ready, development, archived, etc. And starting to manage where they are in that promotion process that I alluded to earlier. And the key thing here is that, again, getting started is really easy. Here I've just shown, like, again, 20, 30, and say 20 lines of code and 10 lines of code, something like that. And that's you doing experiment tracking on the left and model registry stuff on the right. So here I'm on the right, I'm promoting a model from the staging to the production. There's obviously logic I need to build to determine when I want to do that. But again, the actual doing it's quite simple, right? And what I can do is interact with that solution and say, right, give me the production model and then promote that to production, or give me the kind of pre-prod model, and I'll run some tests on it against the production model, compare them and swap them out if I want to. And you just keep building on that. So that's really important as well. You can just get started in this space quite easily. Then what comes to mind is, right, I've got the models out there. How do I know if they're drifting or performing correctly? So again, another very small snippet from the book, such a small snippet of code, right, using the alibi detect package. And that already means I can start building a kind of more complex process that I can keep adding more and more to. So on the right-hand side, I've just taken the typical wine data set, built a very simple drift detector on the data, and just said, does this data drift when I do some stuff to it? You can then start building something that does that repeatably for your predictions, for the underlying data, you know, and then you can start interacting with the previous stage and trigger the model management process to get what the right model is for the right job. And then finally, you can bring all that together to create really sophisticated processes that just take care of a lot of what you're trying to do end to end for you. So on the left-hand side, I've got this process I call the model factory. So you basically build a system that does your training. You then store the models in the model store using the tools and techniques I mentioned. That then feeds into your prediction system in production that does the actual inference of predicting. You then have a drift detector that's looking at the results of that, and then that decides whether to trigger your training system. You don't need to do this automatically. I feel like you could. A lot of places, organizations aren't exactly ready to do all of this automatically. You could do some of it automatically and have manual checks and balances in place, whatever their appetite is there. But what's happened there is very simple steps preceding have led to quite a sophisticated set of things coming together. And then just building on that, you could start thinking about different ways of doing the training piece. So here I've got one of them from the book that I call train persist. So that's where you do persist the model to a model store because you're going to reuse it, or because the training requirements are quite high versus the inference requirements. Where this maybe doesn't apply is if you're doing anomaly detection, or you're doing, say, building a clustering anomaly detection or something like that, an unsupervised learning approach where you want to actually just run in place on the data as it comes in. Then in the book, I call that train run. Maybe not necessarily training, but kind of train run means you're just doing it at the time. And there's no negatives from that. Whereas train persist, you're persisting to this model store, breaking off. And that's you already, again, brought quite a lot together in a short space of time, hopefully, with your projects. And that's it. So I'll kind of finish there, and we'll do Q&A and stuff. So that's hopefully giving you a view of how to make MLOps, ML engineering real. Think about some of the challenges you're going to face on that journey, and just give you give you a bit of a push to just get started and do it. So here's some of the places you can find me. I mentioned the book. I've got co-host the AI Write podcast with Chris from MBN, who works with Robin, and Megan Stamper from the BBC. And then I've got kind of just some other links and things up here. So please reach out and say hello. And with that, I will finish.
Magic beans. That's first class. Thank you very much, fella.
No worries.
Right, you're still sharing your screen, Andy. Can you
stop share?
There we go. Brilliant. Here we go. Right. I'm not going to pretend that I understood all of that, but I did understand quite a bit of it. I've got a very quick question just to kick things off, because we do have some questions from the audience, but a very quick one on my own. So I'm sitting in the audience. I get this stuff. I want to follow the philosophy of Andy. But what resistance and objections would I be likely to see within my organization? I mean, from your own experience, it's not all going to go smoothly. So where are you going to get some blockers?
Yeah, no, great question. So one of the fundamental issues I've seen time and time again that relates to all of this, sort of the basic data science question and then these more engineering focused questions, is just that gap in understanding. So translating for people who are maybe non-technical or not been exposed to this world before, what you can actually do. So there's two ways it goes. Either one, they totally don't believe it. They think it's black magic. No way, I just don't get it. We don't want it. Or they kind of think that there's a way to write down the rules that could do things equally as good or better, right? So that's one form of resistance. The other, which is sort of the opposite of resistance, but can be equally as problematic, is they think it will solve all their problems. And then when it doesn't, they have immense disappointment.
Yeah, so that then
classic, turns to, it turns into rejection later or resistance later. So the key thing there is about the managing of expectations and really having a good concrete way to explain what you can offer as a data science and ML team. So I find it's really helpful to bring to the table examples, but then caveat those examples with obviously what applies to you. So for example, you could go to Netflix and really explain how Netflix use recommendation and your previous user patterns they tailor the experience of how the movies are laid out for you. They also tailor which still from the movie they show you based on your preferences. Don't know if you know that. I found out a few years ago at a talk.
I didn't know that, right?
So even if they show you and me the same action movie, because they know you're artsy and into music, they might show you a kind of cool funky scene from it with some really kind of musical overtones or something. They know me, I'm kind of more in the actual shooting bang bang, so they show the guy holding the gun. They actually tailor what they show from the same movie as well.
Sneaky sausages.
No, it's cool, isn't it, right? So, but the point is, you could bring that or whatever relevant example. Could be whatever for your domain, but you bring that and say, look, this is real and it happens just now.
Yeah.
We maybe can't do that, but what we can do is this, and it's using the same principles that these really successful companies have embedded and embraced. So it's not something that you should challenge too hard. You should have checks and balances and not just run away with it. But I think it's important to manage those expectations and kind of be clear that what the art of the possible is. That works the other way, so people don't think, oh, so it's going to solve my entire problem set and I can just run everything with a robot. It's not possible either. So I think that's a big one for me.
Okay, before we head on to the questions from the community, because there are a couple, just wanted to say big thumbs up from me for any use of a Yoda quote in a presentation. Yes,
like that.
Love it.
Like that.
Miro, how are you doing, fellow? First question from Miro. Given the data science machine learning community is active and there is lots of grassroots siloed approaches to MLOps, and he's quote a little quote here, I just need to deploy my model. Hence, one challenge seems to bring all this together and then group ops, reuse, streamline, model data risk management. And since the DS community moved fast, bringing it together feels like pushing against a tsunami. Did you have this problem? What would you suggest?
Wow, that is a brilliant question. So I think, Miro, this is one of the really big challenges if you are probably feeding into like strategies or programs or strategic direction in the business. This is really, really hard. And it is hard for grassroots teams as well, as you say. So it's definitely a problem I've encountered, and I see speaking to people in my network all the time. So there is a siloed approach, and there's probably where my bias for execution stuff comes back to bite me a little bit. I do think it's important that we bear in mind what I said about tooling being able to swap out. And I think another important point is there's not necessarily one correct architecture for a specific solution. this happens a lot as well. People think there's only one way to do things. I don't think that's true. But what you do have to do if you allow people some flexibility is you have to agree certain standards or certain contracts. So I think what helps challenge this point, Miro, is, in my experience, you kind of try and get agreement between at least the elements that are in your control or more widely across the community is difficult. But say you're in an organization and we say, right, for every data science team or model or project, you're sourcing your data from the data lake and you're using this pattern. And the data lake team can say that because they built the data lake and here's how you access it. Or you all agree kind of this is how we'll access it. That automatically brings some consistency, even though you could go and build things in PyTorch, TensorFlow, Python, Scala, or whatever. If you say, no, you need to get your data this way, that automatically helps some things. And then same thing at the end, where your response is going to go for the output of the model. If you agree that is to go into the data lake or wherever, certain standard place, that helps agree some kind of contract as well. And it starts meaning that the silos become little black boxes, which is its own problem. But I think what it does mean is that everything's not a complete spaghetti. You start agreeing how things hand over to each other. I'm a huge fan of integration points being standardized. So I think, yeah, agreeing you want to touch data lakes a certain way, downstream systems have to get it from the data lake, and it's the downstream system's job to do that, so that you stop getting people who don't know how to build or aren't really fluent in building connections to, say, legacy systems doing it. You kind of separate that out for them. So I think there's that. I don't think it solves the problem, Miro. I think it's a brilliant question. I think that's another talk in itself, or one to catch a coffee about. But I do think there's certain things you can try and push against. It's about agreeing those standards and standard approaches. You then start seeing that actually there's a lot more similar than different.
Thank you. Thanks very much, Miro. David has a question. A lot of the challenges you are articulating regarding the chasm resonate. From my perspective, one of the principal issues is business and tech having a single definition of what production is, and this is usually anchored in the platform and the level of service management wrapped around the solution. What are your thoughts on having more flexible or gradiated definitions of production based on the type of product you're building? For example, different for an ML model queried multiple times per day and used for critical business decisions versus some bespoke analytics and decision support for a non-critical process.
Excellent. Love this, David. So I totally agree. I am a kind of MLEng 101 slide just sketched out some of the stuff for production, and it might have sounded like it was saying once you've got that's it. But I do agree with your approach. I think that's absolutely correct. So if you are running a model that only has to be run, say, once a month, to the results get copied into a PowerPoint, or they feed a dashboard, and there's a lot of understanding that dashboard, the answers they'll come in once a month, but they're there for a consultative basis. They're not there that it's going to automatically make decisions, etc. High latency, there'll be a lot of debate and challenge on the solutions every month at the kind of month end, etc. That obviously has different requirements in terms of service level agreements, in terms of latency, in terms of maybe even code quality, than if you're running something that is, I need to score a credit card transaction for potential fraudulent activity in sub-second timescales, right? There's a whole difference there, and I totally agree with what you're saying. The problem can be you start creating hundreds of different productions, and then we get back to Miro's point, everything becomes a bit of a hellish mess. So I think what's important is kind of either breaking apart the idea of production into a few buckets, or you actually get to the point where you're okay running in certain lower environments potentially for some things. So if you've got dev, pre-live, and live, it might be that dashboard can be fed from pre-live, or it might be that, okay, you push it all the way to prod, but you've just agreed the service levels with your end users and they're very clear. At the beginning of the project, I'd recommend doing that at the beginning. Don't surprise them at the end, but say like, look, because you've got low latency requirements, etc., this thing might run on a Monday, might run on a Tuesday, because we need to give the compute resource to this other thing that runs 100,000 calculations a day, etc. So you could split up production or use lower environments for certain things, for certain analytical activities, or my kind of preferred option would be you just really tighten down the success criteria with your stakeholder, and they understand that sort of, because this isn't the most tightly restricted use case, then a lower service level is probably acceptable, and that could be a good thing for you.
Okay. Thank you, Andy, and thank you for the question, David. Paul's question, any advice for version controlling the models themselves? This seems like it would need a slightly different approach from version controlling code, given the potential size and lack of readability.
Yeah, good. I kind of skimmed over this a bit, but the MLOps 101 slide I had on model management, that's really, for me, model version control. So what you have to do there is, what's important is using whatever tool you're using. Again, I mentioned a few, MLflow and others. MLflow is a good open source one to get started with, right? What's important there is you do understand it is different from versioning controlling codes, as you're alluding to. So there's no concept of a pull request and merging in the code really for a model. You do have atomic models. So if I was to use sklearn as an example, and I export the model to joblib, which is a specific format, that's its thing. I don't then create another one and merge them together. I just create a new one that's better or worse. So the key thing for you managing that in your tool of choice is being really clear on the metrics you want to track. So you could, again, there's multiple approaches. There's no one size fits all. Some people I know, or some ways of doing it are, you agree that for regression, you're always going to track these metrics, or for this other type of model, you're always going to track these metrics, and you do that. So every time you log that model, you've got these 10 metrics that are always standardized, or 5, whatever it is, and they're your kind of standard of truth. So if one's beating the other in the metrics, you know which one should be put into production. And then I think as well, agreeing the process for, this is maybe going beyond version control, but going into the stage of tagging, and then that model registry piece I mentioned. So saying which one is actually the production model now. So it's beating the metrics maybe, but does it have any other behaviors I need to test to make sure are all fine? So just being clear how you're going to manage the tagging, what logic you're going to do, what experiments you're going to run. So you're going to do A/B tests, or you're going to do what we call champion challenger logic. We run a kind of simulated or a set of test data through it, see which one performs better out of live. Different ways to approach it. I do think understanding, like you say, that version control of your code and then model management, model version control are different is good. They are complementary though. So it's just about understanding that difference and making them work together. Hope that answered the question.
Thank you for the question, and thank you for the response, Andy. We've got one here from, it looks like a blast from the past from you, Andy. Gabe Calvo. Hey, Andy. Nice
Hello.
to see you again. Long time since ML Club Glasgow. Here's my question. It is very common to store models as pickle files, which can easily break with new versions of libraries. Do you have any suggestions on how to handle this issue? Should we all move to use ONNX definitions, or have massive across-the-board retraining when the library version needs to change?
Love it. Love it. Hello again. ML Club has been a long time, it's a very long time, Gabe, absolutely. But it's good to see you're still in the community. We didn't scare you off. Great question. I really, really like this question because it's an issue I'm constantly gibbering on about. So I personally don't like pickles, but people always default to using it. So I think if they do use it, it's really widespread, and retraining is an option, like you say, and you can control that process. It's one you might have to go with, at least until you migrate to a better process. I would say avoid it if you can. So joblib, if you're using sklearn, is pretty good. ONNX is good, but I know that's kind of more neural network focused. You could agree a standard JSON format for exchanging models. So you could sort of say if it's regression again, I want to store all the parameters for the regression in a certain format, no matter the library, no matter what type of regression. Might be hard to come up with good standard definitions, but I think there's that. If you're using things like Spark ML, there's MLeap, which is a good format that's quite interchangeable. But yeah, the pickle thing isn't great because of backwards compatibility issues. So you don't want to do that. You don't want to go that route if you can avoid it, I think, because it's just another thing that can go wrong in production that is easy to forget about. So I've definitely seen the case where you do everything absolutely right, you go through to production, and then like you say, we've updated sklearn because we've got a new model, our new feature transformer or something we want to use, or there's some new thing we want to play with. We forgot we need to retrain the model. We try and run an old one and it breaks. And I think there's security issues sometimes with that and with pickle. So I think avoid it if you can. ONNX is good, MLeap is good, JSON if you can make it work. And just I think as well, using things like in MLflow and other solutions, I know there's this idea of packaging an entire sort of environment with it. Sometimes that can help with these questions. But yeah, I think explore it and be happy to use a multitude of solutions, a sort of a lucky bag of these. It's not necessarily that one size fits all again, but I think if you can give people options that are all cross-compatible and help them avoid pickle, that's good. Pickle is good, it works, but yeah, it's got these caveats with it that you need to be aware of. So good question.
Okay, and thank you very much for that, Andy. So with only a couple of minutes to go until the top of the hour, I'm going to bring things to a close there. First things first, I would like to thank everyone in the room, all the community, everybody that's taking time out of their day today. Thank you for being here. Thank you even more for your interactivity. I know, having done these kind of things in the past, it's much better when we get questions. It's much better when people take part. Thank you all so very much, as appreciated. And a massive thank you to published author, Dr. Andrew McMahon. Thank you, mate. Thanks for sharing your knowledge. Thanks for sharing your passion with everybody, Andy. It is appreciated. You know that, mate. Cheers.
Thanks so much. Thanks, everybody.
Thank you, everybody. Take care, and we'll see you all again with another exciting installment some point in the near future. Take care. Bye, everybody. Cheerio.